For reflections, it's a mirror image about a line or axis. Invariant points are the points that do not move after a transformation. So these are very important. You have to know that invariant points are the points that stay, that no matter what I transform or do to them, that the point will stay the exact same as it was when it first started. That's an invariant point. So it doesn't move when you transform the graph. So we're going to look at reflections in the x-axis. Now this is what I need you guys to understand. If I have an x-axis, which is this axis here, okay? This is my x-axis, it's here. Let's pretend. So that would be, if I'm reflecting in the x-axis, that's my mirror. We agree? So if I have a point right here, it's now going to be here. What is being negated? What is being changed the sign of? The x or the y? What's my x on here? 4? Did the x change? If this was 5, this would now be -5. So when I reflect in the x-axis, people think it affects the x things because it's the reflection in the x-axis, it affects the x things. It's not the case. If it reflects in the x-axis, it's actually your y's that are negating, right? So if you have a negative y, it's now positive. A positive y, it's now negative. I forgot something. So we have to remember that when we reflect in the x-axis, it actually affects the y's. And when we reflect in the y-axis, it actually affects the x's. Yeah?
Are we going to be like doing work on this in class or something?
Yeah, sometime. Tomorrow you will. So for sure tomorrow. Okay. So here we have y equals f of x, and then y equals negative f of x. So this one here, is this affecting my x or my y? Is this affecting my x or my y? My y. If it affected my x, it would be in here, correct? So if I wanted to do mapping, my mapping before was adding and subtracting the translations. You guys have textbooks right there, guys. And then you're going to have this one is going to be multiplying by -1. And I'm multiplying my y by -1. Mapping is easy to decide because if it's with the x in your transformation equation, it affects the x's in mapping. If it's on the outside, it affects the y's. So if it's like here and here, it affects the y's. If it's in here, it affects the x's. Okay, so we're going to do x squared minus 4x plus 4 into our calculators. And go. X squared minus 4x plus 4 into your calculators.
What?
Now we want to find the vertex. Now this is a concave up parabola. We learned about that last year. And we want to find the vertex. And if we want to calculate something, we would go second trace, and then it takes us to calculating. My calculator is off. Okay, well that's loading. So if you go zoom 6 as well, zoom 6 sets you back to the standard window in case you're in some wonky window. Zoom 6 will get you back there. So we want to find the vertex. If we go second trace, there's no second trace vertex. But we can go second trace what to get the vertex? Minimum. So we do second trace minimum. And then it says left bound. So you have to be on the left side of the minimum, enter. Right bound, you have to be on the right side of the minimum. Enter, enter. So we go second trace minimum. I have to be on the left side of it, hit enter, on the right side of it, hit enter, then enter. And I get 2.00022, which I can say is 2, right? And then 5.1. So obviously this is at 2 and 5.1 right here. Is that true? No, it's not at 2 and 5.1. It looks like 2 and 5.1 if you don't keep looking at 5.1. What is 5.1? E to the what? -12. So I have 0 decimal 0.00000000000051. What can I round that to? 0. So whenever you see e to the negative anything, that's just 0, right? So we have 2, 0, and we're going to plot that. How do we get more points? We do second graph to get the table. So we have 2, 0 here, 1, 1, 0, 4, 3, 1, 4, 4, and we're going to plot those. Three, 1, 4, 4, 1, 1, 0, 4. And then we just extend the arrows a little bit upwards. We don't want to extend them too far after our last point, or we're just randomly sketching without anywhere to go. So this is our y equals f of x function. If I want to get the actual graph of y equals negative f of x, I can use mapping, because mapping uses points, moves points. So I can go xy becomes x comma negative y. Because my y is being negated, right? It's not my x. If it was my x, it would be with my x. So I can plug in these points. I have 0, 4. 0, 4 is going to become 0 and negative 4. So I'm going to be down here now. 1, 1 is going to become 1 and negative 1. So it's here. 2, 0 is going to become 2 and negative 0. Is there such a thing? 2, 0, 2, negative 0, that's just 2, 0. So we plot that just where it is. Did the point change? Did that point change? No. So that's your invariant point. And that's going to be your invariant point because that is on the axis it is reflecting on. It's reflecting in the x-axis, right? And why doesn't it change? Because the only y I could put in here that by multiplying by negative 1 wouldn't change is if y was 0, right? If y is 1, it'll become negative 1. If y is 7, it'll become negative 7. If y is negative 8, it'll become 8. Those will all change. The only place when you're multiplying a y by negative 1 that won't change is when your y is 0. So that's why this one remains invariant. Then we have 3, 1, which becomes 3 comma negative 1. And then we have 4, 4, which becomes 4 comma negative 4. So when I negate all my y's, if they're negative y's, they become positive, and positive y's become negative. When I negate all my y's, I'm reflecting in the what? Which axis? Yeah.
The x-axis.
Yeah. So this is a reflection in the x-axis. What's another word for x-axis? Does anyone remember? The line? Yeah, but the line what? What line is represented by the x-axis? Something equals 0. Nope. Something equals 0. What's the only thing that equals 0 on that axis? Nope. Axis of symmetry cuts the graph in half. Yeah. Yes. So our actual x-axis is the line y equals 0. Why is it the line y equals 0? Well, every single point on this line, the x's are all different, but what are our y's? What are our y's on the x-axis? 0. So the line y equals 0 is the x-axis. And if you don't remember that, remember like the line y equals negative 7? 1, 2, 3, 4, 5, 6, 7. This would be the line y equals negative 7, right? Because if I wanted to write that, that's y equals negative 7. So this is the line y equals 0. Yeah? Yes. So here it says, state the coordinates of the invariant points. The invariant point is at 2, 0. That's the only coordinate. Says, how does the graph of y equals negative f of x compare to the graph of y equals f of x? It's a reflection in the which axis? In the x-axis, because when your y's move, they're going to flip over the x-axis. The positives will become negative y's, and the negative y's will become positive y's. All right. So how do I determine the equation? So what does this mean? This means I'm going to negate all my y's, all my f of x's. So if this is my equation, if my equation is f of x equals x squared minus 4x plus 4, then what I can do is I can actually just negate the f of x. Well, that looks weird. I wanted an f of x equals. So negating the f of x is putting a negative 1 in front of it. So how can I get rid of a negative 1 and move it to the other side? Divide by negative 1 each term. So I can divide this by negative 1, this by negative 1. So I'm going to get f of x equals negative x squared plus 4x minus 4. Now type this into your y2 once you've written it down. You should get the red graph. So when you type it into your y2, if you have the colored calculators, you're going to have negative x squared plus 4x minus 4. Now watch. Your calculator will draw your graph in order. So it'll draw the first graph, and then it'll draw the second graph. Okay? But then when I go out of here, and I press graph again, they're just drawn. Mine are blue and red, so I can tell the difference. But if you have the calculators that don't have colors, the way you can tell the difference is your calculator will always draw them in order. That is true. That is true. However, if you come back after and you look at it, they're drawn, right? So you don't know which one's which. So what you can do, if you have the colored ones, good, you're done. You have two colors. You're in the same boat as me. If you don't have the colored ones, this is my suggestion. Go down to the second one, every person without a colored calculator, and move over to this slashed line. Mine is a slashed line with a color. Yours is just a slashed line, right? And hit enter once. It's thicker, right? Now press graph.
No way.
Making a thicker line has made you guys so happy. Who could have predicted that? So if you look, the thin line will be your first graph, the thick line is your second graph. Now, I'm going to let you in on a little secret because you're going to stand, there's going to be some of you who are going to sit here for 5 minutes testing out all the different functions of what it can do.
What is this?
Yeah. Okay, stop. I'm going to ruin it for you. If you press the next one, it gives you like a key symbol. It just gives you like little keys along it. You press another one, it gives you a dashed one. You press another one, it shades below. You press another one, it shades above for inequalities. They are useless to you. And if you keep doing them for the next 10 minutes, you will miss everything I teach and you will be lost. Okay. Up to you.
Oh, this key one cool.
Oh boy.
Yo, this one's fire. That one's crazy.
In all of my years of teaching, 18 years, I've never heard someone say this one's fire. Just all right, good talk. Look here. We don't have time for you guys to check out all the fire that's on your calculator. Okay.
I love math. No, I love math now. This is crazy.
Example 2.
This is the best thing I've ever seen.
The graph of, actually the fraction button's the best thing.
Yes.
Well, the fraction one actually.
Yeah. So the graph of y equals f of x is shown below. So this is the f of x graph. They want us to sketch negative f of x. So is this affecting my x's or my y's in mapping? My y, because it affects my y's. This affects my x. So I know my mapping is xy becomes x negative y. I pick 3 points. I usually pick this one and this one and this one. The more points you pick, the more accurate it is. But I'll pick those 3 points, plug it in, and redraw them. So try it out quickly.
Not again.
Okay, so this purple one here, did it change? No. And then this one here, this 1, 0, becomes 1, -0, which is not actually a thing. So did this one change? No. So actually, this here and this here would be called invariant points. Sometimes they'll ask you for the invariant point. Sometimes they'll ask you how many invariant points there are. So sometimes you just list them, sometimes you just have to tell how many there are. So that's a reflection in the x-axis where the y's are being negated. Now we're going to flip over to the next page. And what do you suppose we're going to do? Reflection in the y-axis where the x values are negated. So, now we're still going to use some grade 10 again today. We always use grade 10. Grade 10 comes up a lot. So, here we have y equals f of x and y equals negative f of x. F of negative x. So it's a reflection in the y-axis. Now, why would it be a reflection in the y-axis? Well, if we look at it, if I have a point here and I negate the x, it's now going to actually be over here. I thought I had a different color. It's going to actually be over here. Which axis am I reflecting in? The y-axis. So actually, when you negate your x values, you reflect in the y. Okay. So the first thing we're going to do is re-sketch that same f of x graph because that's the one we're looking at. So we're sketching the y equals f of x graph. Now, if we have a negative here, it's with the x, correct? It's not with the y on the outside. So it's here, it's with the x. So my mapping is going to be xy becomes what? Negative x, comma, y. The y doesn't change. I have a 1 here and I have nothing back here, right? So my y isn't changing at all. Just my x is being negated. So if it's in that bracket with the x, it affects the x of mapping. If it's not in that bracket with the x, it affects the y's. So we're going to test some of these points. So I have 0, 4. And it's going to get me negative 0, 4. Is that a thing? No. So what's happening here? That's the invariant point. Why is it invariant? It doesn't change because that's where it reflects on, correct? So we know that we're multiplying all of our x's by negative 1. The only time our x won't change when I multiply by negative 1 is if our x is 0. So it's the y-axis that will remain invariant when you have a reflection in the y-axis. The next one is 1, 1. It's going to become negative 1, 1. So it's going to be here. And then I have 2, 0. It's going to become negative 2, 0. And then I have 3, 1, which is going to become negative 3, 1. And then I have 4, 4, which is going to become negative 4. This is y equals f of negative x. So this is where we're going to go back to grade 10. In grade 10, your teachers gave you f of x functions. They were usually linear because all we talked about in grade 10 was linear, quadratics in grade 11, and absolutes. And then in grade 12, we talked about all of them. But in grade 10, your teacher would have given you this. Something like f of x equals 3x minus 2. right? Nice little linear equation. And your teacher told you, don't freak out. F of x is just y, not a big deal. But they did teach you how to use function notation. It was the first time you were taught how to use function notation. So if your teacher gave you this, they gave you f of 2. What did that mean? X is now 2, because look, it's in the same spot, right? So they want you to put a 2 in. So you would have done 3 times 2 minus 2, and you got 4. And I'm not sure if you knew this, but you found a coordinate. This is my x, and the output, my input is x, and my output is y. So I got a coordinate, 2, 4. So I got one coordinate that was on this graph. That's all I did. And I could input another value and get another value out. Input another value, get another value out. And you did t-tables in junior high, which did this. Input, output, input, output. Okay? Now let's go to grade 12. What if I don't use a number? What if I say f of a? What would that just mean? A is x now instead of a 2. So I'm going to go 3a minus 2. Okay, what if I did this? What would I do? X becomes negative x now. So I would get 3 times negative x minus 2, which is actually negative 3x minus 2. We agree? So the previous one we looked at in the last part of the lesson was this. And all I did was, okay, when they gave me that, I just put a negative in front of my f of x, right? This time they're going to give me f of negative x. So what am I going to do? I'm going to take all my x's out and replace them with negative x. That's why you get taught this in grade 10, for this very moment in time. You didn't even know it. So here we have f of x equals x squared minus 4x plus 4. That's my original. They want us to get the equation that represents f of negative x. Okay, well that's not bad. I just go y equals, now instead of that, every x I'm going to put a negative x in. So when I put it in, I should put it in brackets. I'm going to put a negative x there and a negative x there. So I'm going to get negative x squared minus 4 times negative x plus 4. What is negative x squared? It's just x squared, because the negative gets canceled. Because anything squared is just itself twice multiplied, right? So negative x times negative x is x squared. So make sure we're writing this down. And then negative 4 times x is positive 4x plus 4. Okay, put that into your y2 and see if you get the black graph. Every time you clear your y2, you clear the thick line, just so you know. You have to redo it every time if you want it. You should get the black graph, right? And it's reflecting in the x-axis. So what's the invariant point? The invariant point of this one is 0, 4. How does the graph of y equals negative f of negative x compare to the graph of f of x? This is a reflection in the what axis? It's in the y, because my x's are swapping over the y, right? So it's actually in the opposite axis than what you think. Because if it's negating my x's, it's going from here to here, here to here. It's going over the y-axis, right? So it's the opposite. So this is a reflection in the y-axis. Then we're going to flip over. So we're here. I want you to take this graph and we're going to sketch this one first. So please go sketch this. What would my mapping out of this be? xy equals negative xy or xy equals x negative y? Which one's negated? Yeah. So it's the y that's being negated. It's x negative y, because remember, it's not with the x. Whatever's with the x goes with the x in mapping. Whatever's not with the x goes with the y in mapping. So this is going to become x comma negative y. And we have all these points we can apply it to, right? So try it out. So if we just look at A for now to get B done, cool, but we're not, I'll give you time to do that in a second. If you look at A for now, and I ask you how many invariant points there are, you guys will always be drawn to the bolded points. Do you see the bolded points? Everyone paying attention? Because on the test, when you only give you the bolded points, you're like, this is Lepp, we've never discussed this. I'm going to say September 19th at approximately 26:14, Mrs. Lepp said this. You will be drawn to the bolded points, okay? So how many invariant points are there? Most people will tell me 2. And you're like, I'd say 3. Not on the test, you won't. You'll say 2. 2 is wrong because you're usually drawn to these bolded points here. Do you see them? So they'll say 2. But this one here as well, even though it isn't a normal, like, solid point right through one of the cross sections, it's still invariant, right? It still is on that x-axis. So when you have a reflection in just the x-axis, nothing else happening, just a reflection in the x-axis, nothing else happening, then your invariant points are on the x-axis. Okay, you guys try B if you have. Okay, so if we look at this one, it's, xy becomes negative xy. So if I took negative 6, 0, it's going to become negative and negative 6, so 6, 0. So here. And then if I take negative 4, 6, it's going to become 4, 6. So here. And this is here. And then 1, 2, 3, 4, and 2, 3, 4. Like that. And then like that. How many invariant points does this one have? It just says 1. Where is it, Jesse?
It's right off the y-axis.
Yeah, it's right here. So when we have a reflection, and only just a reflection in the y-axis by itself, the invariant point is on the y-axis. The next one, some people get stuck on, they don't know which is the reflection, if it's on the x or the y. But the giveaway, if it's only a reflection in the x or it's only a reflection in the y, is to look where the invariant point happens to be. So, if we look at example 6, for example, where is the invariant point on A? Where is it crossing? It's here on the x-axis. So I know there's a reflection in the x-axis. When I have a reflection in the x-axis, what does that look like on an equation? Y equals negative f of x or f of negative x? Negative f of x. Because if it's a reflection in the x-axis, my mapping is actually negative y. Right? My y's are being negated. So I would actually get a negative in my y. And for B, the invariant point of this one is on the y-axis. So it's a reflection in the y-axis, which means my mapping would be xy becomes negative xy, because it's the opposite. The reflection in the y-axis, it has to be my x's being negated. Ones are here, here. Ones are here, here, right? And then how does it look like on my equation? Y equals f. Yeah.
Relates to x and negative f of x equals mx.
No, well, this one wasn't as specific because they didn't tell you what the equation is. You went off it being linear, but really what they would have done is they would have said, okay, well, this is y equals f of x, and then you would have done it properly. So it's, you're not wrong because they didn't really label the equation properly.
So, just for like the mx minus b, we have to write the minus b, or would that be?
It'd be negative mx minus b technically because it's a downward slope, but they're not going to test your linear abilities. They're going to, yeah, for this one. This one here says write the equation of the image. So after reflection in the y-axis, if it's a reflection in the y-axis, my mapping would be xy becomes what? Reflection in the y-axis. I'm up here. I'm over here, then I'm over here. I'm over here, then I'm over here. What becomes negative? Yep, x. So my x's are going to be negated in my equation, right? So I go to where my x is and I negate it. So it's y equals 10 to the negative x. That's it. After a reflection in the x-axis. So now we're reflecting this way. We're reflecting my x-axis. What's being negated? My y. So the xy becomes x comma negative y. So I would negate my y. So I'm going to get negative y equals root x. Just won't often be the option. They'll often have it in y equals, so we have to still divide by negative 1, and you don't just let it sit on the bottom. You just write it in front of the term. Because root x divided by negative 1 is just negative root x. Then we're going to flip over. We're skipping the top example. I used to teach this after rationals and radicals, so the top example worked because you actually knew what a rational graph was. You don't, so I won't give you rational ones on this test. So we're going to bypass this one because you don't know what rational graphs even look like, so they would look super confusing. So we're going to go to these two instead. So here it says, as 9, given y equals root x minus 2, find y equals negative f of x. So where would the negative go this time on that equation? With the y or with the x? With the y. So I would get negative y equals root x minus 2. And then what do I have to remember to do? Now this is where people mess up because they want to put it inside that square root symbol. Can I put it inside the square root symbol? No, it sits in front. So I get y equals negative root x minus 2. For b, where does that negative go? With the x or with the y? With the x, it's with the x. So I'm going to get y equals square root negative x minus 2. Now you could put the negative in brackets, but in this case doesn't do anything different because there's no number in front. So you could write it like that or like this. You guys try example 10. So the equation of the reflection in the y-axis. So if it's in the y-axis, what does it affect? X. So I'm going to get y equals negative x squared plus 1, and I need to put it in brackets. So I actually get y equals x squared plus 1. Wait a tick, it's the same equation. How does that happen? Well, x squared plus 1 has a vertex at 0, 1. I know that from grade 11. And then it does something like this, a little something, something, a little something, something, and it looks like this, and it looks like this. So when I reflect it in the y-axis, what happens? This arm goes on that arm, and that arm goes on that arm, and you end up with the same graph because it's symmetrical about the y-axis. We agree? So then I get people telling me, well, Mrs. Lepp, it's invariant everywhere. Invariant, the definition of invariant means it did not change. The point did not change. So is this invariant everywhere? No. It's invariant on the y-axis. This arm here will end up on this arm here, and this arm here will end up on this arm. Those moved, correct? So the only invariant point is still on the y-axis. But sometimes when you apply a reflection, the equation doesn't actually change because the equation itself, or graph itself, is symmetrical about what you're reflecting, right? If the graph is symmetrical about the x-axis and you reflect it in the x-axis, you're going to get the same graph. If it's symmetrical with the y-axis and you reflect it in the y-axis, you're going to get the same graph. Now this one, we have a reflection in the x-axis, so it's going to be a negative y. So I'm going to get negative y equals x squared plus 1. This one gets done badly because people want to put the negative 1 in front of the other side and just say negative x squared plus 1. However, when you divide the negative 1 over, you have to divide what? Every term. So I never just put one line and put a negative 1 under it if there's more than one term. When we've done it in the past, there was one term that I applied it to and I was done. But if on the right-hand side there's more than one term, always divide every term separately by negative 1 so you don't mess up. So I divide this one and I divide this one, and I get y equals negative x squared minus 1. Done. So that's how you won't mess up. Okay?